Hey everybody, welcome to today's video where we're going to be looking at how to order our numbers that are written in scientific notation. In the past class, we've talked about how to convert between scientific notation and standard form. And so here in this video, we'll get started just reviewing a few of the key advantages of writing our numbers in scientific notation. First, you can see we have listed here that scientific notation just simply makes it much easier to manage larger numbers when performing arithmetic problem solving. Basically, when we're looking at things like finance or really large numbers or teeny tiny decimals, actually. Also, if you're thinking about a career or a future with space and NASA or SpaceX and things like that, when dealing with really large distances, for example, from here to the moon, stuff like that is written in scientific notation. For a blank space here, to fill in the blanks with your notes here, we've got scientific notation ensures accuracy. It just means that we're more accurate, and it reduces the possibility of error when using those very small or very large numbers. Think about the difference in 1-0 if you're typing numbers in for banking or if you're looking at how much money you have in your bank account. So we write numbers in scientific notation just to reduce the possibility of making any mistakes when working with those large numbers. And lastly, we can see here that scientific notation simply allows numbers to just be read more easily without the distraction of non-significant values. And what we mean by that is back on one of the pages where there was like a 7.0000000000002. This stuff right here is kind of considered non-significant. This number right here is basically a 7. And that's what we mean by a non-significant value. These are just kind of non-significant. That number is mostly a 7. Okay. All right, now let's just see a few examples here. And you don't have anything written down here, so you're going to need to take notes on this part. But if we want to know the number 1 million written in standard and scientific notation, well, here it is in standard form. I already have it highlighted in green. That's what a million looks like in standard form. If we talk about 100 million in standard form, it looks like this. And if we talk about a billion written in standard form, it looks like this. So that's what a million versus 100 million versus a billion looks like. Now, again, with all those zeros, you can see it'd be really easy to make a mistake when writing either a million, 100 million, or a billion, which is why we want the thing over here in scientific notation. It just means we're not going to make a mistake writing this out. So that said, to remind you guys, to make a million in scientific notation, we just need to count if the decimal was right here. 1, 2, 3, 4, 5, 6. So this is a 1 times 10 to the 6th power. 100 million, we would count back 1, 2, 3, 4, 5, 6, 7, 8 times. So 100 million is 1 times 10 to the 8th. 10 to the 8th is 100 million. And a billion, y'all, if we count, that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1 times 10 to the 9th, a 10 to the 9th there, that's a billion. So seeing the 1 times 10 to the 6th, that's a million. 1 times 10 to the 8th, that's 100 million. And 1 times 10 to the 9th, that would be a billion. All right. This might look familiar here when we compared decimals using the less than, greater than, or equal sign. So let's just do a quick refresher on how we would compare these values right here. And I think, let me double check where the decimal would go. There should be a decimal written right there. All right, cool. So when we're looking at comparing the 0.2124 versus the 0.0772, this first number, y'all, the 0.2, that is already bigger than this 0.0. So already this one is a bigger decimal, okay? Now, if we saw the 3, 5, and the 1, and then a 3 and a 5, they're tied at the 3 and the 5. The 3 and the 5 tie. So now we have a 1 here, and you might remember that that could be a non-significant value. That's just a 0, a placeholder right there. And we can see here that the 1 is bigger than the 0, so that would be a greater than this way. All right. Now, when we're looking here, the examples that you have, I'll have it boxed here in red. This is what you guys are seeing now next in your notes. This example, and this example. So now basically it's a similar concept where I want to look and see which side's bigger or smaller than the other and use these greater than or less than or equal signs. And I'll show you guys underneath it to just kind of review the last topic, like the video from the last class. If you saw 4.2138 times 10 cubed, that just means to move this decimal over once, twice, 3 times. So really on this side, the number that we're looking at is a 4,213.8. That's what's on this side. Now on this side, the 7 would mean we need to move that over 1, 2, 3, 4, 5, 6, 7 times, and we get this number down here, the 22 million. So I think when we're looking at these numbers, it's really easy to see that 22 million, y'all, is way bigger than something that's in the 4,000s. Now this step down here, this was us taking it from scientific into standard notation, standard form, so we could compare. But I'm going to highlight something and see if some of you can notice a little shortcut. If the exponent here is a 3 versus the exponent here is a 7, which one's bigger between 3 and 7? Well, 7's much bigger. So you can use the exponent here as a little shortcut. And if you think about it, multiplying something here times 10 million, 10 to the 7th is a 10 million. That's going to be a way bigger answer than if we only multiply something by 1,000. So this side puts us in the thousands. This side puts us in the like 20 millions. And so this side is much bigger. Okay. Now let's move on to the middle example. Okay. So the shortcut, some of you are already trying to look at it, and we've got a 5 here and a 4 here. And so yes, that means because we're multiplying this side by 100,000 and this side by only 10,000, yes, we're anticipating this side to be much bigger. And of course, if we use the 5 to move the decimal to check, I could see 1, 2, 3, 4, 5. So this number is 509,600. 509,600. Now, if I only move the decimal over 4 times, 1, 2, 3, 4, I'm at 50,960. So when we're comparing something that's in the 500,000s versus in the 50,000s, of course 500,000 is going to be much larger than just 50,000. Now for the last one, you guys can kind of see here with the note taking. Now I'm setting us up for an example where, okay, here there's a tie. And if the -4 and the -4 show up on both of them, you might be tempted to put an equal sign there. But let's look. On this side, we have a 2.124. And on this side, it's a 7.052. Now notice what they both have in common. We can see here the 4 zeros, -4. The 4 zeros here, -4. So up until then, they're tied. But now it's a lot like what we used to have to do. We have to just go decimal by decimal and compare this 2 to the 7. And right here, this 7 beats the 2. So this side is bigger. So here's the one catch, y'all, the one catch for today's notes. Yes, you can use the exponent. If the 7 is bigger than the 3, cool. If the 5 is bigger than the 4, cool. But right here, if they're tied, it's not always going to be an equals. You have to actually look at the values. And since 2.124 is less than this 7.052, we're going to see that less than symbol right here. And again, the 2 is less than the 7 in the decimals, and that's how we made that decision right there. So you can use the exponents as a shortcut, but if the exponents are tied, then you have to use this number over here to see which one's bigger or smaller. Okay? All right, so let's practice. We're going to practice ordering now. We've got 1, 2, 3, 4, 5 numbers, and we're just going to order them from least to greatest. I'm not going to do any converting. I don't need to see what the numbers actually are. I'm going to only look at the exponents. So my shortcut says I can see here I'm multiplying basically times 10,000. For this one, I'd be multiplying, we said that 10 to the 8th up here, we said that that was 100 million. This is going to be going the other way and make a super teeny tiny decimal. This is going to be times 10,000. And again, this is going to make a super teeny tiny decimal. So let's focus in on the negative ones real quick. We had a -2 and a -6. So between -2 and -6, which one is a smaller number, y'all? -6. So the lowest value we're going to have on this entire list is the 2.37 times 10 to the -6. Then we would have the 5.96 times 10 to the -2. So 5.96 times 10 to the -2. All right, we took care of our negatives. Now we have a 4, an 8, and a 4. Now we mentioned when the exponents tie, we have to look at these numbers right here. So this one is going to be 47,800. If we convert this, this is 47,800. And this one would be 60,200. So between those two, obviously 47,000 is smaller than 60,000. So like I said, if the exponents tie, 4.78 is smaller than the 6.02. All right. So we took care of the tied exponents, and again, 4 came before 6, so that's how we decided there. And last but not least, something times this one right here, which is, we set up here 100 million, 10 to the 8th is 100 million. So 3.4 times 10 to the 8th is going to be 340 million, which is by far the biggest number in our list, so 3.4 times 10 to the 8th. So to sum up, we should be able to see our exponents in order from least to greatest, and these values do go in order from least to greatest. And when there's a tie like here and here, this went from least to greatest. All right, and now we have one more here to try. So again, let's just go after our exponents. I see a -4, a squared, a -1, a cubed, and a -4. So let's practice with these negatives here. If we have a -4 and a -4, let's just look right here at this number and this number. Okay, this one is going to be a 0.00053. This one's going to be a 0.00017. So again, the -4s, they tie. And you can see here the tie is that there's the zeros tying, there's the -4s. And now between 53, y'all, and 17, which one's a bigger number? 53 is bigger than 17. So we found the smallest one right here. The 17 is the smallest. So even though I'm not writing it in the blank, you guys can write it in the blank, but we have the smallest one now is the 1.7 times 10 to the -4. And then it was the 5.3 times 10 to the -4. So again, the exponents tied, but we ordered the 1.7 and the 5.3. So they tied, but now these are in order. All right, and now we have another negative exponent, the -1. So the 8.96 times 10 to the -1. And now for the positive exponents, the 2.04 times 100, this is going to be 204. So 2.04 times 10 squared. And this one right here times 1,000, this is going to be 2,550. So that's going to be the biggest number we have in our list here. So the 2.55 times 10 cubed. And again, to check our final answers, we should see the exponents going in order from least to greatest. -4s, -1, 2, and 3, those are all in order from least to greatest. And right here, when there was a tie, we're checking, and 1.7 to 5.3, that's going from least to greatest there. Okay? All right, that concludes today's video. There's some practice waiting for you afterwards. Thank you for watching.